This video is going to be a little more confusing than most, but it's quite interesting, and I think I see the problem, or why it ain't doing what I want yet. Okay, so power supply, and I'm going to show the anomaly too, something weird that's happening. I think I understand, but not sure. Okay, power supply. Positive comes to an amp meter, so we could see amps without them flicking around. Out into a diode of an H bridge, which the positive feeds in. Negative from the supply goes right to the negative of this H bridge. So this is right off the supply with a diode right there. Okay, that comes out with pulsing AC, or square wave rectified AC, modified AC, into this choke transformer. It's a nice one. I got it off a treadmill. Okay, and then back into itself. That raises my flyback. Now, because I'm separating, as you see, I got two diodes there. Okay, this is just a multimeter lead. Now, both these diodes are going into my hot. Okay. Now I have off this one, I have it going out, around, on the red wire feeding hot in here. The negative wire is this blue one, comes around, goes through an amp meter, then it goes back to the same terminal as my power supply lead before it goes through the meter. It goes right to the hot terminal. As you see, this black one is on a hot terminal, and this is also on a hot terminal. And I'm going to have about 12 volts in between them when I start this up. So I'm going to run, so that's the the back EMF. So this thing creates a bunch of back EMF in polarizing direction, amps one way, volts the other, and it raises my voltage up to 2 times my input voltage, which I'm going to put 6 volts in. So I'll have 6 additional volts out of there. And that's going to go and run my motor. And that's going to put 6 more volts of back EMF going in there, which is going to bring my multimeter up to 12 volts. I'm going to run this with 12 when I'm putting 6 into here. Now, something's funky about the amps. I'm going to explain that afterwards. And if I put in another diode and not letting this energy from this back EMF, if I don't let it go to the supply, it won't run, because the voltage gets stepped up way high in this. Also, because it starts sending voltage in a correct direction, that the back EMF combined with this back EMF is always a smidge under, so it can't loop back into itself. But anyway, I'll show you. So I'm going to show you 2 anomalies, but first let's get started. 6 volts, had that locked at 4 amps all the way up almost. We're going to start it. This is what I'm running the motor off of. 11.7 volts. And again, these multimeter leads are hooked up to the hot terminal here, right? And the black multimeter lead is hooked up to this hot terminal, which comes back on a black wire right to this hot terminal. So I'm measuring from here to here on either side of those diodes on that hot terminal. I have just about 12 volts in between these 2 diodes that are both tied into the hot terminal. And I could run the motor with that back EMF going the wrong, and this is sending back EMF going the wrong way. Voltage is going this way, it's back EMF's coming this way, and I'm tapping that back EMF to run my motor. My motor's creating back EMF going towards this, but it can't get into this. It has to go into the supply. So it's quite an interesting setup. Now I'm at my 12 volts. Okay, so I'm up to speed as high as I can get it. Now, even though I'm only inputting 6, it's saying jumping around because it's actually saying over 6, but it's really 6. Watch, it's 6. And when I put a multimeter on the leads, it'll say 6. It'll say 5.98. But I don't want to unhook it right now. Anyway, so I'm putting 6 in. We're running the motor with 12. And something interesting is I'm using more amps than I need to use with this. So it's not over unity or anything. But anyway, so now this is measuring amps that I'm pulling from the supply. 1 amp. Okay? 1 amp. Now remember, I had this locked at 4. Watch what happens when I lower. Let's lower it to 2. 2.2. My motor dies. Even though now it's only pulling, I don't know, half an amp, 6/10 of an amp, 600 milliamps. But I have to keep this up to like 4 in order for it to go. So something's happening with the amps where it's, even though it's only using 1, I have to allow it to pull up to 4. I don't quite understand that part yet. Okay. Now, I've tried putting a diode here just to let the hot in one way, but not let the back EMF that this is creating go into the supply to force the back EMF back into the circuit. Just try to force it that way so it feeds itself. But it won't do it because, as I said, this goes up to 12. Okay, wait, I'm going to stop it quick. The motor stopped. It's only 5.8 for 5.5 a back EMF. But when the motor goes, it starts inducting itself. And it'll go up to about 12. As you saw, it'll go up to 12. But look at the volts that are in this transformer. 14, 13.9. So 12 ain't going to flow into 14. I'm 2 volts shy. If I could get this up to 15, then it'll flow that way. I could put that diode there, I think. And then loop it back into itself. But until I could get these volts higher, I can't do it. The other option is, I don't know, use a booster, maybe. But I don't know yet. But I really want to, now it's going over 12. I really want to take this back EMF that this is producing, brings it up to 12, get it over 14, stick a diode, and then have this voltage feed back in to see if it'll continually go up and not stall out at this point. But anyway, so the anomalies right now are, why do I have to let this power supply go up to 4 amps? And this ain't hot. That's cool to the touch. But I'm only pulling 1. But I have to allow more through. Is it because I'm putting? Is it because that's generating amperage and it's putting it in, so the meter there has to accommodate for both ways? I'm not sure. Anyway, so that's where I'm at. We'll try to get more.